Today we are going to discuss about third application of Pascal's law, that is Mercury barometer. It is generally used for the measurement of atmospheric pressure. In the textbook of physics, Maharashtra State Board, the atmospheric pressure throughout this chapter is denoted with the notation P naught, that is P naught is equals to atmospheric pressure. This instrument is also called as Torricelli's instrument, that is used for the measurement of atmospheric pressure, and it was designed first time by Torricelli. It consists of one tube 1 meter in length, which consists of mercury, and that mercury is filled in this tube up to the brim. In another container, open container, which also consists of mercury, and is kept to the open end of this tube, and it is inverted into another container containing mercury in such a way that air cannot pass into the mercury. So that is like upside down, which is shown in this figure. But as this end is open, so some part of mercury from this tube, it will spill out of the tube, and there is a formation of this vacuum that is called as Torricelli's vacuum. This portion may contain mercury vapors too. Let us assume the highest point of this height of mercury, that is at point A, which is in contact with this Torricelli's vacuum, or it is simply a vacuum, which is up to height h from the outermost level of the mercury. It is denoted with this height h. Height of the mercury in the tube is denoted with h. Let us assume two different points, point C, which is outside the tube, but in the mercury, which is in contact with the air, and that is on the surface of mercury liquid. At the same height but inside the tube, there is another point, which is point B here. So as per the mathematics or logic, pressure at the point B is equals to pressure at point C. The reason behind it is what? They are at the same level in the same liquid, therefore pressure at that point, that is equal. Now coming back to the discussion which we already had about if a free surface of some liquid, if liquid is at a height h, then pressure at that point is calculated as pressure at the point B, which is Pb is equals to pressure at this point A plus pressure due to this height of the liquid. So this will be, it can be written as Pa plus H rho G, where this rho is the density of mercury. Pressure at the point A, as if the point A is in the vacuum, therefore pressure at point A is equals to 0. Therefore substituting this pressure at point A in this equation as 0, pressure at the point B, it will become H rho G. Now let me number this as equation number 2. Put 1 in 2. So on substituting 1 in 2, we get Pc is equals to H rho G. But as the point C, which is in contact with the atmosphere, therefore this pressure Pc is nothing but the atmospheric pressure. So Pc is equals to, for atmospheric pressure, notation used is P naught, already we have stated here. Therefore putting this Pc here in this equation, we can get P naught is equals to H rho G. So this is what the atmospheric pressure that is calculated by first time by Torricelli, and so the instrument designed is known as Torricelli's instrument for the measurement of atmospheric pressure. Thank you.